Okay, for problem number one, we are given a function that is in factored form, and we have to rewrite it into standard form. So to do this, I'm going to multiply the two binomials together. You can use FOIL. I'm going to use a box or the area model. So I get x squared negative 4x, 2x, negative 8. These are like terms. So the standard form is x squared minus 2x minus 8. But we're not done yet. We have to multiply this trinomial by 3. So f of x is equal to 3x squared minus 6x minus 24. Another way that you could have solved this problem is if you had done the distributive property on the first binomial. So if you had multiplied 3x minus 12 times x plus 2 using the area model, you would have also gotten the same solution. Be careful. One of the biggest mistakes that I saw was people distributing the 3, but they were distributing to everything. That's not how it works. You would only distribute it to the first binomial. Okay, write the function in vertex form. So now that we have a function in standard form, I'm going to use that as my starting point to rewrite it in vertex form. First thing you want to do is factor out the leading coefficient, but only from the first two terms. A lot of you were factoring out the leading coefficient from the constant, and as a result, you got the incorrect vertex. You see, you just rewrite the negative 24 below. You don't do anything to it. Okay. So in here, we're going to add something, and then in here, we are going to subtract whatever it is that we added. What would make this a perfect square trinomial? Negative 2 divided by 1 is negative 1, and negative 1 squared is 1. So if we're adding 1, we should also subtract it, but watch out, you didn't just add 1. You added 1 times 3, which is 3. So f of x is equal to 3. What's the factored form of this perfect square trinomial? Well, two numbers that multiply together give us 1, but added together give us negative 2, is negative 1 and negative 1, and the factored form of that is negative 1, x minus 1 squared. And then negative 24 minus 3 is negative 27. The vertex is the opposite of that, and the same number on the outside. So positive 1, comma, negative 27. Okay, what is the y-intercept? The y-intercept is a constant when it's given to you in standard form, so 0, comma, negative 24. The discriminant. Okay, so in number 2, you're given a function and you're asked what the discriminant is. Remember, the formula for the discriminant is a portion that is inside the radical in the quadratic formula. So b squared minus 4ac. Our b is negative 4 squared minus 4ac. (16 minus 8 times negative 6), so 16 plus 128, which is 144. What was the biggest mistake? Some of you put a minus sign here. A negative times a negative is a positive. So your discriminant is 144. How many x-intercepts will you have? You will have 2 x-intercepts, and these x-intercepts will be rational. Why? Because our discriminant is a perfect square, which means that if I put that number inside the radical, right, in your quadratic formula, this is the portion that's inside a radical. Well, the square root of 144 is a whole number. And on the bottom of the quadratic formula, you have what? 2 times a. Isn't this portion also going to be a whole number or a fraction? Yes. So you have an integer over a whole number or a fraction. It doesn't matter. Your result will still be a whole number or a fraction. And whole numbers and fractions are rational numbers. Irrational numbers are, okay, irrational numbers in this specific context refers to x-intercepts whose solutions contain radicals. There will be no radicals here because the square root of 44 is a whole number. If you need to study this, come to tutoring, look up this information on the internet, study. Do not sign up for a retake if you do not fully understand this. You will not do well on the retake. Okay, number 3. What if I tell you that you have two numbers? Ignore this problem for a minute. Y times z, and I told you that if you multiply these two numbers, you get 0. What do you know about the letter y and the letter z? If you said that the letter y or the letter c or both must be equal to 0, then you are correct. Same thing here. Just because your y value and your z value are binomials instead of just single numbers, that's still the same thing. Why? Because you have two factors, and these two things are being multiplied together and they equal 0. So either factor 1 is equal to 0 or factor 2 is equal to 0 or both are equal to 0. All of that to say that all you have to do is set each of those factors equal to 0 and solve for x. The opposite of subtracting by 5 is to add 5. The opposite of multiplying x by 6 is to divide it by 6. So x is equal to 5 over 6. Same thing here. We have negative x is equal to negative 4. This is a mistake that made me very, very sad. The invisible number on the left side of the x is a 1, right? And the operation happening between the two is multiplication. We're multiplying x by negative 1. The opposite of that is to divide both sides by negative 1. Those of you who were adding 1 to both sides, that is not an okay mistake to be doing in Honors Algebra 2. You need to know that you're multiplying by negative 1. It is not okay to do that again. Negative 4 divided by negative 1 is a positive 4. Also, those of you who were multiplying these two binomials together just to factor them, that was crazy. Don't do that. Number 4. Panchito is selling Kit Kat bars for a fundraiser. He determines that the profit in dollars for selling each Kit Kat bar at C price can be determined by that function. Okay, so I know that because I have a negative leading coefficient and a second degree function, that my graph should look something like this. It's going to be an upside down U because of that negative leading coefficient, and it's going to be U-shaped because it's second degree. What else do we know? We know that P of C is an isolated variable, so meaning there's nothing in front of it, there's nothing behind it. So this has to be my output. Now, the variable that does have things going on for it, that one will be your input. So C is the value that goes in my x-axis. So I have a function here. I have a relationship between the cost of each Kit Kat bar and the profit that I make, or that Panchito makes from selling each Kit Kat bar. Profit, and then cost per Kit Kat bar. On your retake, if you do not write cost per Kit Kat bar or cost per whatever thing it is, if you just write cost, you will not get any credit. Because I need to know that you understand the relationship that is happening here. I need to know that you understand what the graph means. Okay, letter C, you get 3 points. 1 for finding the x-intercepts, 1 for finding the y-intercepts, and 1 for finding the vertex. Let's find the x-intercepts first. I'm going to take the equation that was given to me and set it equal to 0. Because if you're finding the x-intercepts, you are finding the value of your equation when your profit is $0. Okay, I'm going to divide everything by a negative 3. So I get c squared minus 10c minus 7 is equal to 0. And I'm going to solve for c by completing the square. So I will add 7 to both sides and have this c squared minus 10c plus something is equal to 7 plus something. Because if you do something to the left side of the equal sign, you must also do it to the right side of the equal sign. I know that when you guys are completing the square, you usually skip a couple of steps ahead, but what that ended up resulting is that you fail to see the relationship between how completing the square means making a perfect square trinomial on the left side of the equal sign. And that took points away from your essay on the next page, right? The question was asking you, how do perfect square trinomials relate to completing the square and solving quadratic equations? This is how. Okay, the number that has to go here is 25, because negative 10 divided by 2 is negative 5, and negative 5 squared is 25. So if I'm adding 25 on the left side of the equation, I should also add it on the right side. Okay, let's factor this. Two numbers that multiply together give you 25, but added together give you negative 10, are going to be negative 5 and negative 5. And 7 plus 25 is 32. And another way to write c minus 5 times c minus 5 is c minus 5 squared. Again, you guys usually skip to this step, but you need to understand that the only reason why you were able to get to this step is because this is a perfect square trinomial, and this is a factored form of that perfect square trinomial. Okay, now we are going to square root both sides, and we end up with c minus 5 is equal to the square root of 32, and c minus 5 is equal to the negative square root of 32. I'm going to figure out what the square root of 32 is so that I can get a decimal approximation so that I can plot it on my plane. So the square root of 32 is between the perfect squares 25 and 36. The square root of 25 is 5, the square root of 36 is 6. If 32 was dead center between 25 and 36, my answer would be 5.5. But that's not really true. 32 is 7 units away from 25 and only 4 units away from 36. So it's actually closer to 6 than it is to 5. So 5.5 is not a good approximation. 5.7 is okay. I would have given it to you if you had said 5.8 or 5.9. Okay. So let's substitute that. C minus 5 is equal to 5.7, so C is equal to 10.7. And C minus 5 is equal to negative 5.7, so C is equal to negative 0.7. And these are my x-intercepts. I'm going to go ahead and plot them. $10.7. Okay, and then before I find the vertex, I need to use my brain a little bit. This is about -1 and this is about 11. So my vertex has to be somewhere around 5, right? The halfway point. And I'm going to use that information to make sure that whatever answer I get for my vertex, that it makes logical sense. Okay, I'm going to find the vertex of this function by rewriting the function that was given to me in standard form into vertex form. I will not be using the formula negative b over 2a because rewriting this function to vertex form is way more elegant, and 2, you're less prone to make mistakes if you don't have to substitute anything back into the original equation. Okay. Let's see. Let's start by factoring out the -3. So we have c squared minus 10c plus something plus 21 minus something. Okay, right, we already know that that number is going to be 25, and we should be subtracting negative 75. So now we have negative 3 parentheses. Again, this is a perfect square trinomial, and the factored form of this perfect square trinomial is c minus 5 squared. And 21 minus, oh, did you see that mistake that I made? That should have been a negative. So minus negative 75. I will get 21 plus 75, which is 96. So my vertex should be 5, 96. If you want to use a formula negative b over 2a, that's fine as well though. Okay, so first I know that my y-intercept is 21, and then my max is going to be 96. Remember, this is not up to scale. The x value we said should be around 5. It ended up being exactly 5, which is great. And now I'm just going to connect the dots carefully. Bam. At what price should Panchito sell each Kit Kat bar? He should sell it at $5 each. And his max profit will be $96. At what price should Panchito sell each Kit Kat bar to break even? The answer to that is $10.70. So at this point here, he will not make any profit, but he will also not lose any money. What that means, and that's for this portion, pay attention because I'm not writing it down. What that means is that he's probably going to sell a couple of Kit Kat bars to offset the cost of, I don't know, buying the box of Kit Kats and selling them and going to Costco and gasoline. But he's not going to make enough money to actually turn in a profit. Why? Because $10.70 is way too much money for a Kit Kat, so he's probably not going to sell as many. Right? The sweet spot's over here at $5. If he sells them at $5, he's going to make profit. Now, if he goes past $10.70, he's actually going to be losing money. He's going to be selling even less, which means that he will not even make up the cost of money that he spent getting those Kit Kats. So that would be the answer for that. Why do you think this is part? And I would do the essay question on a separate video.